Here there is one more question where you apply the concept of conjugates and a lot more other things. So actually the concepts which I have used to explain this problem are a lot more advanced, which you find in the later part of the complex number. So you'll have to listen very carefully to understand all these aspects, because it is taught in advance. So the question here is, find the least value of the positive integer n for which root 3 plus I the whole power n is purely real, that is A, and B purely imaginary. So what should be the least positive integer? So they make it very clear it has to be the least positive integer, because if you put n as 0, it becomes purely real. That is, if anything power 0 is 1. So that option is ruled out. It has to be a positive integer. So first thing I am doing is I am writing this in polar form. Actually this is the second form of complex number. First one is the rectangular form. The given question is in rectangular form. So in order to solve this problem in a proper logical way, I want this complex number to be expressed in the polar form, which is r into cos theta plus I sin theta, where the r is called as the modulus and theta is called as the amplitude. So when you write like this, the real part of this number is r cos theta and the imaginary part is r sin theta. When can two complex numbers be equal? When their real part and real part both sides are equal, the imaginary parts on both sides are equal. And that is exactly what I have written here. I am squaring and adding these two equations. R cos theta square is r square cos square theta, square of the right is 3. R sin theta square is r square sin square theta, square of the right is 1. Now these two equations are added. R square cos square theta plus r square sin square theta can be written as r square common into cos square theta plus sin square theta. The right side is 4. So this bracket becomes 1. So it's r square is 4. R is equal to 2. We shouldn't write plus or minus 2, as r is a modulus, which is nothing but the length of a line segment. It has always to be positive. So now I substitute the value of r in this equation. I get cos theta is root 3 by 2 and here I get sin theta is half. So you should get a value of theta for which both these equations will coincide. And that value is 30 degree, or rather pi by 6 radians. So substituting for both r and theta in this form, I get root 3 plus I as this. So what is root 3 plus I the whole power n? It is the whole right side raised to power n. So 2 power n into the power n of this is according to de Moivre's theorem. When you apply power n for a complex number in this form, the power n comes and multiplies the amplitude. So I have written the power here. Because it is positive integer, we are applying de Moivre's theorem. That's also something which is going to come in the later part of the complex number study. So this is written according to that theorem. Please understand. So this is our z. So what is z bar? Z bar is 2 power n into cos n pi by 6 minus I sin n pi by 6. Only the sign of the I term changes, or the imaginary part of the complex number will have a change of sign. Now we come to the question. We are supposed to find the least positive integer value for n so that the complex number is real. The condition for the complex number to be real is z should be equal to z bar. So I am writing z is equal to z bar here, and here 2 power n cos n pi by 6, 2 power n cos n pi by 6 will cancel. So what remains is 2 power n I sin n pi by 6, and one more 2 power n I sin n pi by 6 comes here. So 2 power n into 2i sin n pi by 6 becomes 0. So all these terms cannot be 0. So only sin n pi by 6 has to be 0. And this happens, sin theta becomes 0 either for theta 0. The next is when theta becomes pi. This will be pi if I substitute n as 6 here. So the least value is 6, because 0 is ruled out. It has to be the least positive integer. So it has to be 6 here, so that it becomes sin pi and it will become 0. Then z has to be purely imaginary, that is subdivision b there. So this happens only if z is equal to minus z bar. So I am substituting that. So what happens is minus 2n cos n pi by 6 will come here. So that will come this side and get added. 2n I sin 2n pi by 6 and plus 2n I sin n pi by 6 here also will cancel. So these two terms are getting added. So again this term will become 0 only if cos n pi by 6 is 0, and the cos theta becomes 0 when theta is pi by 2. So to make this pi by 2, what happens here? You have to substitute n as 3, then only it becomes pi by 2. So the least positive value is 3.